Welcome to Maths for You YouTube channel. A past question on mechanics. The question from Oxford and Cambridge past paper. Figure shows two blocks at rest connected by a light inextensible string which passes over a smooth pulley. Inextensible, therefore no stretch, and the light, there's no weight, and again smooth pulley, there's no friction in that pulley. That's what the wording give us. Block A of mass 4.7 kilogram rests on a smooth plane, so there is no friction, plane inclined at 60 degrees to the horizontal, and B of a mass 4 kilogram rests on a rough plane. Yes, that's a friction involves. Inclined at 25 degrees to horizontal. On either side of the pulley, the string is parallel to a line of greatest slope of the plane. This is another extra information. Block B is on the point of sliding up the plane. There's another information. As a diagram given, block AB, and the incline A inclined is 60, B inclined is 25. So that the tension in the string is 39.9 Newton, correct to three significant figures. Let's do this first. As a little sketch of the same diagram, but I've marked all the forces. So the diagram is given 60 inclined and 25 inclined to be side. Okay, the block A has forces act on it. So the string is upwards, the T tension, and the downwards along the plane or parallel to plane is the portion of the actual weight. So that is 4.7 kilogram sine 60. And again, the plane reaction forces to A is RA, and again the weight act on that plane is again portion of the actual weight, 4.7 kilogram cos 60. So there are four forces. One is a downward 4.7, the weight portion of the block is 4.7 kilograms sine 60, and T is the tension upwards, and again perpendicular to the plane is RA and 4.7 kilogram cos 60. Right, and then again tension, the smooth play, therefore the T all along the string is same. There's no different because of this smooth play, there's no friction, so single string, so T is same. So when you come to B, the forces acting on them, of course T parallel to the plane, and the force parallel to plane downwards is the weight portion of the weight is 4 kilograms sine 25, and again the reaction, the plane reaction forces is RB, and again the weight portion of the weight on plane 4 kg cos 25. But because of this rough plane, there should be a friction as well. I just marked it as a downwards F. I'll explain to you why I marked it as downwards. Right. First of all, we need to find the tension first. So is equilibrium. So we can, at equilibrium, the object not moving. Therefore, the forces acting on that object has to be a zero on a particular direction, or zero at all. So if you look at it, parallel to plane, there are two forces. One T, the other one is 4.7 kilograms sine 60. One going upwards, one going downwards. Therefore, if I use that, 4.7 kilogram sine 60 equal T, straightforward equation. And when you go to B, as there are parallel to the plane, the T upwards, and 4 kilogram, the portion of the weight and the friction is downwards. So 4 kg sine 25 plus F equal T. So there are two equations, one for A, one for B. Both are at equilibrium, not moving, so the no forces are equal. Therefore, these two equations. From equation 1, a simple calculation is T. T equal 4.7 kilogram. So G, we need to 4.7 kilogram, and then we need to make a force. So we need to consider the gravity, 9.81 times sine 60. That give us, if you use the calculator, that give us 39.9 Newton. That's the first question which we need to show. That's done. So second equation, we can separate F to left hand side, the other T minus 4 times 9.81 times sine 25 the other side, and T is 39.9 and minus 4 times 9.81 sine 25. Again, use the calculator. The answer, I just made it to 3 significant figure rather than keeping more values, 23.3 Newton. So F, the friction on that rough plane downwards, downwards, if I put it upwards, it would have been minus. Anyway, that's one reason. So 23.3 Newton. But the very important message from the question, at the point of sliding, means this system just about to go up, so just moving upwards, so about to go. As it's about to go upwards or downwards or whatever, the point of sliding, at the point of sliding, we know the F equal mu RB, that's another formula, is F is the frictional force, mu is the coefficient of friction, and RB is the perpendicular reaction from the plane. So first of all, I wanted to find out RB. If I could use object B, object B on the direction of from the plane, this is one. RB is that direction, and the opposite direction is 4 kg, cos 25, 4 kg, cos 25, that's the one. So from that, we can find R. So 4 times 9.81 cos 25, calculate again, 35.6 Newton. So RB, we know that. If we already found it from the previous, and all we need mu. So mu equal F over RB. F is 23.3, RB is 35.6, just found. The answer is 6.5. The coefficient of friction is 0.65. Thank you. Please subscribe the channel and send some comments with all your questions, and share the contents with your friends and other students. Thank you.